Have you ever wondered how a simple shake of your flashlight brings it to life? Or how your electric car manages to recharge its batteries? The answer lies in a fundamental principle of electromagnetism, Faraday's law of electromagnetic induction. This principle, named after the brilliant scientist Michael Faraday, is a cornerstone of modern electrical engineering. Understanding it can unlock a deeper appreciation for the devices we use every day. To begin with, Faraday's law revolves around three key concepts: a magnetic field, a conductor, and relative motion. Picture a loop of wire, our conductor, situated within a magnetic field. If the magnetic field through this loop changes, for instance, by moving the loop or changing the strength of the field, an electric current is induced in the loop. This is the heart of Faraday's law. A changing magnetic field induces an electrical current. The greater the rate of change of the magnetic field, the greater the induced current. But there's a twist. Faraday's law also involves something called the direction of the induced current. This is dictated by Lenz's law, which states that the induced current will always be in a direction that opposes the change in the magnetic field. Imagine it as nature's way of maintaining balance. Now let's apply this to real life. In a power generator, for example, a coil of wire rotates in a magnetic field. The rotating motion changes the magnetic field through the coil, which in turn induces an electric current. This is how our homes, offices, and cities are powered. Or consider the humble electric toothbrush. When you place it on its base, the base's coil and the brush's coil form a transformer. A current in the base coil creates a changing magnetic field, which induces a current in the toothbrush's coil, charging the battery. In conclusion, Faraday's law of electromagnetic induction is a fundamental concept in electrical engineering. It explains how changing magnetic fields can induce electric currents, with the magnitude of the current dependent on the rate of change of the magnetic field. Lenz's law adds the directionality to this induced current, ensuring it always opposes the change in magnetic field. From the simple flashlight to the complex electric car, Faraday's law underpins much of our modern world. So next time you flick a switch, spare a thought for Michael Faraday and his groundbreaking law.